Next, we move on to feature binning. So df is equal to df.copy. This basically creates a copy of like the data frame for us to work with, as it allows us to make any modifications without messing up like the original data frame over here. Then we move on to features to bin brackets age and cholesterol. Then we move on to if df process comma cholesterol is equal to 0 dot any print number of 0 values in cholesterol df process brackets cholesterol is equal to 0 dot sum. Basically what this block of code does, it basically handles any of the 0 values in the cholesterol column, which may like indicate like there's like missing data. Next we move on to median cholesterol is equal to df process brackets df process cholesterol greater than 0 cholesterol dot median all the way to print replaced 0 values with median cholesterol. What this block of code does is basically replaces the zeros with the median of the non-zero values for the cholesterol column. So here we have the number of zeros in the cholesterol column, which is like 172, and now it's being replaced with 0 values with the median, which is now 237. Next we move on to from scalar learn processing import standard scalar k-bins this coder there. So we're basically in this block code, we're basically binning ages into category. The first method is manually binning based on like domain and knowledge. So basically what this block of code does is basically this creates like a bin based on like the medical knowledge about like age risk groups. So age bin is defined as 0 all the way to like 100. Basically this defines like the boundaries like from like under 40, under 45 to 55, 55 to 65, 65 and all the way up to 100. Then we have age labels is equal to a young adult all the way to elderly. And then we have df process age bins is equal to pd.co df process brackets age bins is age bins labels equal to age labels. But basically what this does is that pd.co basically creates like a new categorical column by assigning each patient to one of these bins over here. Next we move on to method 2, which is like equal width binning with using k-bins discretizer. Basically k-bin age all the way up to data processed age width is equal to k-bin age fit transform brackets data process brackets age as type int. Well, basically what this code line of code does is it creates like bins of like equal width across like the age range, and k-bin discreditor is initialized basically to create like 4 bins with like ordeal encoding, and strategy is equal to uniform to ensure that like each bin covers the same age group, and therefore like the resulting columns contain like values from 0 to 3 representing like the 4 equal width of bins. This ensures that there's like equal representations of the entire age spectrum. Next we move on to method 3, which is equal frequency binning quartile based. So k bins age quantile is equal to all the way up till data processed age quartile is a k bins age quantile dot fit transform brackets data processed brackets age as type int. Well, basically what this line of code does is basically creates bins with like approximately like equal number of patients in each as strategy is equal to quantile. This ensures that each bin contains like roughly like the same number of like observations, and this creates like an age group based on like the actual distribution of like patients age, and this basically balances like the number of samples in each bin. Then we move on to like visualizing each of these methods. So the first one we have is manual billing by using SNS count plot with these parameters. Then the next visualization is equal width binning, the quantile binning, and then here we plot it over here. So here are the 3 visualization, the heart disease by age group, the manual bin. So there seems to be like less heart disease for younger adults and middle age. However, there's more for like seniors and then elderly, and this is true for equal width method. And then we have the quantile method, which shows that young adults have a higher chance of no heart disease. However, middle-aged people have like equally amount of heart disease and non-heart disease. Seniors have more likely to have heart disease as than elderly. Next, we move on to binning cholesterols into category. The first one we have is method 1, which is manually binning based on the clinical categories. Basically what this line of code does is this: it creates like medically meaningful cholesterol categories such as like 0 to 200, 200 to 240, 240 to 600, and these are like based on like clinical guidelines for like cholesterol risk levels. And then we use the labels as desirable, borderline, or high for like standard medical terminology. And then we do df.process cholesterol bin equal to pd.col data process cholesterol bins, call bins, and labels, call labels. Basically, pd.col assigns like each of the patients into the appropriate cholesterol category. Next, we move on to equal width binning, which has k-bins call equal to k-bins descriptor with these parameters, and df process equal to cholesterol equal length, k-bins call fit transform df process brackets bracket cholesterol as a type. Basically, what this block of code does, it basically creates like bins of equal cholesterol range by using k-bin deserizer over here with like strategy equals uniform that creates like 4 bins with like equal length, and encoded is equal to ordinal, which returns like integers labels from 0 to 3 for each of the bin. Next, we move on to method 3, which is equal frequency binning quantile based. Basically, k quantile is equal to k bins with these parameters, all the way to data process cholesterol quantile is k bins call quantile fit transform df process brackets cholesterol as a type int. Basically, what this chunk of code does is create bins with like approximately like equal number of patients as strategies equal to quantile. Basically, this creates bins roughly like the same number of observation in each category. And this approach basically adapts like the distribution of the cluster values in this specified data set. Then we move on to visualizing each of the methodology. So we do sns.count plot with these parameters for the manual bin. Then we visualize equal bit winning and then quantile width, and then we plot them over here. So here's our visualization. So here we have the visualization for heart disease by cholesterol levels, which is the manual bins. So here we have like the number for the desire, borderline, and high. Then we have the heart disease by cholesterol level, which uses the equal width bins. Here we have for 0, 1, 2, 3. Then the heart disease by cholesterol level quantile from 0 to 3. Next, we move on to df process equal to pd.get dummies p df process columns is equal to h bins cholesterol bin and drop first false. Basically, what this line of code does is it converts a category of bin features such as like age and cholesterol bin into like a binary matrix representation, as it basically creates a new binary column for each of the category and each of the bin feature. Then we move on to bin columns equal to call for call in df process.columns if age bin is in call or cholesterol bin is in call. Basically, this line of code creates like a list of all the new one-hot encoded columns using like list comprehension, and it basically filters out the data frame columns to find like those containing like age bin or cholesterol bin, and then we print out the bin columns over here. So new bin feature columns include age bin young adult all the way till cholesterol bin high. So yeah.